Hey everyone, I'm Tarun and today we are going to be talking about arrays in Java. So arrays are a very core and an important part of every programming language. In this section, we'll be learning exactly what these arrays are and how to write them in Java. We'll also be learning about how to read the input for these arrays from the user and how to write the output. We'll learn of a new type of loop, that is the for each loop that works on these arrays. And while we are at it, we'll obviously be solving a few problems to get a better understanding of what these are. So let us dive into values of the same type in a sequential manner. So let us try to understand this with the help of an example. So let's say that I'm required to compute the average of the marks of a given class. So let's say I have some 50 students in my class. I'm provided their marks in a particular subject and I want to report the average of those marks. So to do that, the first and the foremost thing is obviously going to be that I need to be able to store all of that data, and only then I can perform some operations on top of it. So to store the data, I would probably create some variables like these. For the marks of the first student, I could create a variable called marks1, and for the marks of the second student, I could create another variable like marks2 and so on. Now this solution is obviously not the right solution. This is not maintainable, scalable, or handleable in any possible manner. So let's say that I have a class of 1000 students, because then obviously it will go out of our hands. So now let us try to find a simpler solution for this. But before that, let us limit the scope of this example so that we can make it easy to work. So for now, let's just say that the size of the classroom is 10. Let's just assume the class size to be 10. So for 10 students, I would probably create 10 variables like these, marks1, marks2 up till marks 10. That would store the marks of 10 students. Now, obviously, even this is not the right solution. So in order to store the marks of 10 students, creating 10 variables will be hectic. So what I can do is I can simply store all of them with one variable. I can store them, handle them, and maintain them with just one variable. And the way to do that is by creating a variable of array type. So an array allows us to store multiple values inside a single data structure. So to create an array in Java, we would write something like this. We write the data type over here. Then we denote it by square brackets. So square brackets denote the existence of an array. We name the array as marks. Since we are storing the marks of students, we choose the most appropriate name, that is marks. We use the new keyword. New keyword allows us to allocate some memory to it. We'll understand how it works in the memory in just a few seconds. And then we say that the memory must be of integer type and we want 10 blocks of it. So let us try to understand how it works under the hood. So when I execute this statement, what happens inside the memory is that I'm provided with a block, something that looks like this. So this is what my marks variable will point to. So marks variable will have like this. It will have a block of memory assigned to it where we'll have 10 buckets. Since we declared the size as 10, so we will have 10 buckets. Each of these boxes is actually a bucket of integer type only. So each of these boxes over here, these 10 boxes, each of these boxes are able to store integer types of values. These are equivalent to an individual integer variable. Each of these boxes have some, as you can see, they have a number assigned to them. So the first box has the number 0, then the second box has the number 1, and then 2, and then 3, and so on up until 9. So these numbers that have been assigned to these boxes, these are called the index, or the plural word for this is indices. So we use these index or indices to refer to each of these values. So basically, if I say print the value of marks of 0, so I'll use square brackets for this. So if I say print the value of marks of 0, what it will do is it will go to index 0 and it will print whatever value is there. So in this case, it is going to be 0. Initially, all the values are assigned 0 only for integer types of arrays. So initially, all values will be 0. Now let's say I want to update some value. So I can say maybe marks of, let's say 4 is equal to 20. So what this statement will do is it will go to the block with index 4, this block, and it will go over there and it will update whatever value is there. So in this case, it will be updated to 20. So we'll have a 20 over here. Similarly, I can write marks of, let's say 2, and let's give it a value of 10. So in this case, it will be 10, just like that. So the numbering of the indices always and always start from 0. So the first index is always and always 0, and the last index is always equal to n minus 1. So this is the end index, and it is always equal to n minus 1, n over here being the size of our array. So in this case, we had an array of size 10. So that is why the last index came out to be 9. We can refer all of these boxes, all of these blocks of integer types just by referring to their index. And this block of memory is contiguous. So that means that these 10 blocks, these 10 integer blocks exist contiguously inside our memory. So these were assigned continuous place one after the other. So now let us go back to our code. So now over here, I have a marks array with the size 10. So now what I can do is I can start assigning the values of the marks of the students just like this. So maybe I can say that the first student had marks 10. So I can say marks of 0 equal to 10, marks of 1 is equal to 20, and so on. And I can even print these values. I can read or write to them just by referring to their indices. And let's take it a step further. So if the values are known at the time of the declaration itself, if I know what values I'm trying to store inside the array while I'm declaring it, then I can declare it something like this. So I can say int marks with square brackets, of course, over here, and I will initialize it to an array right over here. There's the data to be wrapped inside curly braces, and you just write the data in the order that you want it to be. So in this case, what will happen is that we will get an array. 1 will go at the 0th index, 2 will go at the first index, and so on. And the best thing about this is that the size of the array will be determined automatically. So in this case, the size is still 10. So the size of your array will be determined automatically. Java interpreter will automatically understand it and allocate appropriate memory for it on its own. So let us go to our code and see it in action. So over here, I have my IntelliJ IDEA, and I'll create a marks array, and I will give it a size of 10. And what I'll do is, let me initialize some of the blocks with some values. Let me say in marks of 2 is equal to, let's say 56 maybe, and marks of 5 is equal to, let's say 70, and the rest of the values will be zeros only. So if I print marks of 0, marks of 1, let's say, let's also print 1, note that we have not initialized any value at marks of 1, and let me print marks of 2. So if I run this program, you will see that for marks 0, I get the value 10 that I had initialized. For marks 1, where I had initialized no values, I get 0. And for marks 2, I had initialized it to 56, I get 56. Now the question is, what will happen if I print the marks variable itself? What will happen in this case? So let us try it out. And once we execute this program, you will see that I get an weird output like this. Note that this output would be different for every system. So this is not a consistent output. So what this is actually the memory address. So this is actually the memory address where my marks variable was pointing to. So let us go back and try to see. So as I had told you over here, that the marks variable will be pointing to the beginning of the array. So over here, marks array is pointing at the first location. So somewhere about over here, it is pointing at the beginning, the very first beginning of the very first beginning location of your array. So you get, when you print the value of the marks variable, you will get the address of this particular location, the very first location. Okay, so that is what we get in our output. Now another thing to notice, and a very important thing, is that the arrays can be declared of any type. It's not specific to integer values. We can have arrays of all the types. So maybe I can have, so let me create another array. Let me call it float ARR. So I'll give it a size of 5. And similarly, let me also create another array of strings. I'll call it names. And this time, let me do an initialization over here. So I'll say, I'll just give it some random names. Okay. And now I can print those names if I need. And I'll print names of 1 as well. And I will print int cannot be converted to float. Okay, my bad. I had declared it over here as int. So if you're declaring a float array, then you must allocate it float value only. My mistake. And since now we are at it, let us also print the values of some random value of the ARR array as well. Note that I have not initialized it yet. So let's just try to print the default values. So now when I execute it, you see this was the previous output from these print statements. Now for the ARR, I get the default value for float array as 0.0. So for integers, it is 0. For float, it is 0.0. And I can also see my names of 0, that is Luffy, and names of 1, Zoro, being printed over here. If you are interested in printing the size of your array, you can simply do that as, let me print the size of the names array over here. So I'll say names dot length. So just by writing dot length in front of your array, it will give you the size of that array. So arrays in Java are processed as objects. If you do not know what objects mean, do not worry, we'll be seeing that later on in the OOP section. And the arrays can be declared of any type. So we can have arrays of int, float, long, short, all those primitive types. We can have character arrays, Boolean arrays even, and we can also have arrays of non-primitive types. So over here you have seen we had an array of a string. If you create your own type using a class, you can create an array of that as well. We can have arrays of arrays as well. So even that is possible, and we'll be looking at it in the future lectures. So that's it for the arrays introduction. Hope you got a good idea of what arrays are and how we can work with them. And I will see you in the next lecture. Thank you for watching. Hey everyone, I'm Tarun, and today we are going to talk about input and output for arrays. So in the previous lecture, we learned what arrays are. Now let us talk about how we can read the input for arrays from our user and how we can show an output for the array, how we can show all the values that are given to us in our array. So let's say that I have an array over here, int arr, and I will initialize it with the size 5. Now let's say that I'm looking to read 5 integer values from the user and I want to store them inside my arr variable. So for that, since we want to read 5 inputs, so maybe we can do something like this. Arr of 0 is equal to sc.nextInt, and then we can say arr of 1 is equal to sc.nextInt, and then so on. So for a small size such as 5, of course we can write 5 statements. That is of course possible. However, if the size of the array were large, then it would not be feasible to do this. Over here we notice that we are practically doing the same thing. I mean, these two statements are practically the same except for the index. So what we can do is we can wrap this logic inside a loop. So maybe I can write a loop such as for int I starting from 0, and I will go up till the size of the array. So in this case it is 5, or I can say arr dot length. In case I'm not sure what the size of the array is, I can just iterate to arr dot length, and in each iteration I will take the input as arr of I is equal to sc dot nextInt. So let us run this. and let me give it 5 integer values. So I'll give it the values as, let's say 5, 2, minus 10, 3, and let's say 0. So you can see that my program worked successfully. Now let us also try printing out some of those values so that we are sure that it's working fine. So let me print ARR of 0 and ARR of, let's say, 3. So I'll of course have to execute it once again. So I'll give the values as 5, 2, minus 10, 3, and 0. So now you can see I've got 5 and 3 as the output, which is the correct output, of course. So let us try to understand how exactly this worked. So we had ourselves an array indexes as 0, 1, 2, 3, 4, not indexes, indices. So what happened was our loop, it ran from 0 till 5. So in the first iteration, I was equal to 0 and ARR of I translated into ARR of 0. And I said ARR of 0 is equal to just whatever the next integer returns. So in this case, it was 5. So 5 came and got stored over here. Then in the next iteration, the value of I increased to 1. And then we were reading the input for ARR of 1. So the input came as 2 and the value 2 was stored over here at the first index. Similarly, in the third iteration, the value of I increased to 2. So we were storing the input in ARR of 2 this time. And the value came as minus 10. And that value got read and stored inside this bucket. And similarly, in the next iterations where I was equal to 3, I got the value 3 over here, coincidentally. And for I is equal to 4, I got the output as 0. And when I printed ARR of 0 and ARR of 3, the values 5 and 3 were printed to the console. So this is how we can read the input from the user with just this simple loop. So this is the input loop. Now let us try to understand how we can print the output as well. So printing the output is even more easy. So for the output as well, we will be having a loop. So I'll have for int is equal to I is equal to 0, I less than ARR dot length, and I plus plus. And this time we'll be just printing the values of ARR of I. Since we can refer to each value by their index and the indices are varying from 0 till n-1. So over here, I is also varying in that exact same range from 0 till n-1 only. So that is why when we refer to ARR of I, it will just give us the values at each index one by one. So let us try to run till n-1. Indices will be just print But is even more easy. ARR of 0 and ARR of 3, the values 5 and 3 were printed to the console. So this is how we can read the input from the user with just this simple loop. So this is the input loop. Now let us try to understand how we can print the output as well. So printing the output is even more easy. So for the output as well, we will be having a loop. So I'll have for int is equal to I is equal to 0, I less than ARR dot length, and I plus plus. And this time we'll be just printing the values of ARR of I. Since we can refer to each value by their index and the indices are varying from 0 till n-1. So over here, I is also varying in that exact same range from 0 till n-1 only. So that is why when we refer to ARR of I, it will just give us the values at each index one by one. So let us try to run this code. And let me give 5 values as input. So I'll give the file values all in one line this time. So I'll say 5, -1, 2, 0, let's say 7. And as soon as I press the enter and I provide the 5 values, it reads these 5 integers one by one. And over here, we can see these outputs being printed with this loop. So I can maybe modify it. So I can say at index is equal to I, we have the value is equal to ARR of I. So let us modify it like this to see a better output. And I'll give the values again. So we see at index 0, we have 5, at index 1, we have 1, at index 2, we have 0, index 3, we have -4, and index 4, we have 3. Now let us take this one step even further. So currently we have hard coded the size of the array. Now what if I want to take the size of the array as input as well? Now even that's also very easy. So I can just create a variable over here. I'll say int n is equal to sc.nextInt. And while declaring the size, instead of using the value 5, I'll just say n. That's it. Now when I run this program, I can give the size maybe as 4 this time, and I will give it 4 values. I'll say 9, 8, 1 and -3, let's say. And you can see that I get the correct output for it. So that's it. Reading and writing the output for an array is that simple. We can do that with just 2 very simple loops. So that's it for this session. I will hope to see you in the next tutorial. Thank you for watching.